In this segment, I'm going to show you how to download the required EV3 NXT module so that your Labview that you might have on your own laptop or home computer can be used with Lego. So if you just run the basic Labview, it's not going to have the Lego module in there. So the easiest way you can get the module is coming over to the M Courses folder on any MCC computer and double clicking on that. You're going to of course go to ENR and then Engineering 161 and WADC, and then we have some Lego resources in here. Now in here is an 2015 NXT. So this is something that you'll want to copy onto your computer, and then when you double click on it, it'll ask you to extract this, and then this will allow you to install your Lego module. Now if you don't want to do it this way, you can go directly to National Instruments. Let me just go back. All right. To get to this screen in National Instruments, if you in the search bar just type in Labview EV3 download, and you hit this right here, it'll come up, and you're going to want the 2015 module. Do not take the 2016. That's not going to be compatible with our computers on campus. If you happen to have the Labview 2016 on your laptop, then of course download this one. But I think most of you are running the 2015, at least this fall 2016. But that's how you get that, and you can click on this and download. Now I've already done that step for you and have it downloaded right here on the M drive. Now there's some other things in here that we'll be referring to. There's the Tribot building directions, so you'll want to avail yourself of that. The recovery from clicking brick syndrome, you might get that. It's the clicking brick is like a whooping cough, so you need a little remedy for that, and that's what it is. Light Calibration 2 Fall 16. This is a nice piece of software that I created that's going to allow your light sensor to work flawlessly for line following. Okay, this is worth $1 million, but available to you at no extra charge for your tuition. The inventory, some charger instructions. Let's see what these instructions are. These instructions are no longer needed, I don't think. But anyway, they're there. Base robot build. Oh, that's a little robot. I guess you could make that one. We're going to probably be making the Tribot, which is this one. But we're not going to put the claw on it. All right, so there we go. So that's what's in there. So you'll need to do all that stuff in order to get your Labview working with Lego. So let's get into our first VI, and this is what we're going to build. And what I did is I targeted, when you open up your Labview, it's generally going to look like this. Okay, so there's going to be the regular buttons over here on the left. When you want to use the Lego, you need to target this to the NXT EV3. So you click on that, and when you do that, this gets all the menus and stuff ready to work with the EV3. Now there's two run buttons now. The first run, what it does is takes your program and downloads it to the EV3. When you do it this way, the program just gets downloaded, and there's no further communication between your computer and the EV3. There's a second way to run, which is called the debug mode. And if you want to ever use the front panel either to send data or to receive data from the EV3, you're going to want to use the debug. That sets up a two-way communication between your computer and the EV3. All right, so now over on this side, let's take a look at building our first VI. In our first VI, we're going to just do something simple where we're going to display things onto the EV3 screen, just to show you how to use the screen. And I've got some things written. Now, normally if you right click over in the block diagram, you get all these functions. You'd have to go down to robotics, okay? Not even robotics, that's not what you want. You want Mindstorm Robotics, and then this Mindstorm Robotics palette is where you're going to get your things from. Now, it's a little easier if before you get started, you go ahead and do your target to NXT. So whether you have a brick connected with the USB cord or not, you can do this. All right. Now, if you look down at the lower bottom, this brick that I have is labeled H8. That's Honors Kit number 8. Now, when you have the deployment to the NXT, then when you hit the right-click button over here, the only functions that are going to come up are the ones that you can use for the EV3. Now, in the programming, there's a lot of the same stuff we've been using. The input outputs where you're going to get a lot of your sensors, all your sensor and motor inputs. And then that behaviors, I never even use the behaviors, okay? Does that mean I'm misbehaving? No, it doesn't. Just things I have good behavior. But if you are ever bad, go into the behaviors here, okay? Alrighty, so let's see. I've got a while loop, easy enough. We know how to create while loops now. So let me just show you where to find the poly display, poly wait, and poly display. Okay, so I'm going to right click. You're going to go to I/O. Okay, well, come on. Oh, it's being a little unruly here. Okay, I'm misbehaving. Okay, I/O. Let's go to display quickly. Okay, so let's bring the display down here. We don't need this one. Okay, so there's the display. It's set up to use text. All right, there are other things you can do. You can write text. That's what we're going to do. You can align it different ways. You can send integers or floating point. I've never used the draw stuff, but you can draw stuff. I guess erase stuff. You can play with that. I even tried brick light. I don't know what it is. All right, so let's right click on that, visible items, and label it so everybody knows that's the poly display. When you use the poly display, you're going to want to send some kind of text to it, and that's what this lower left one does. So I right click, and I could create a control if I want my text to come from the front panel. If, however, I'm planning to run this program in autonomous mode or without the front panel, then I'd want to just simply create, right click, create a constant, and I could write some message like hello world here. And then that's just part of the program, and it doesn't require the front panel. The other thing you're going to have to tell this thing is what line do you want it on. If you don't put a line in here, it's probably going to default to the first line. So you right click on here, and you could create, in this case I'm going to create a constant, and then there's 12 lines that you can go on. Okay, up here in the program that you're going to write, you're going to create a control instead and put an integer in there, and that way when you run this program, you can go and, while the program is running, change the line number. If I do it this way on the right side, the line number is fixed, and I won't be able to change that during the execution of the program. All right, so that's the poly display. The poly wait, okay, that's right click, go to I/O, and there's a wait for. Okay, wait for. Okay, let's bring that in. Wait. So I'm going to right click, show you that that is indeed the poly wait. You're going to wait a certain amount of time in seconds. I right click on here, create a constant, and right now that's 1 second of wait time. So I'm going to display some text for 1 second. I'm going to display some text. I'm going to wait 1 second. Then I'm going to clear. Now to clear text, I'm going to use the poly display. Too many polys here. Okay, and come down off of text, and I can go to erase screen. Okay, and that'll come up with clear. So that's all you do. Now these three things here, okay, these magenta lines, or hot pink lines, whatever you want to call them. Okay, what these do is force the program to execute in this order from left to right. If you don't put these lines in and you just go like this, Labview will figure out when it wants to do any of these things. It might clear it, then wait, then put the text. So to make sure that there's a certain execution order, you use these NXT EV3 terminals and you put them together, and that forces an execution left to right. I could then run this program and change my line number, change my text, do all kinds of things. You can have the fun doing that. All right, so that's our first VI. Have fun with it and get to know your Labview EV3 brick. Now in this VI, known as doorbell, we really don't have anything in the front panel. I don't even need this out there. We're not going to use any front panel. We're going to use a button on the EV3 to just create a doorbell. All right, so we're going to create a while loop, and inside that while loop we're going to put a case structure. So I'll just quickly create that here. We're going to go structure, a while loop. Now over here on your while loop, I'm going to right click and just create a constant, which is false. It's going to come up false. If I click on it with the finger, it goes to true. And what this is going to do is keep the program running pretty much indefinitely. Okay, so that's our while loop. Now inside that while loop, I want to put a case structure. So I can come in here. Now the reason I'm getting the full menu is because I haven't targeted to EV3. So you might want to target to EV3 before you start programming. That way you get the more truncated function list. All right, you're going to have to find these things in programming, structures, and I'm going to go to a case structure. So just create a little case structure here. So I've going to have a couple cases, true and false. Okay, the poly sensor, we're going to right click, we're going to go to I/O, and now we're going to go to sensors. We throw a sensor in there. Now this sensor has a big drop down menu. I'm going to move it up a little bit. It's got a big drop down menu. Got to get the finger first. There you go. And I'm going to go to read brick buttons. Okay, so click on that. Now it changes to NXT buttons. So it's going to read buttons. Now I have to decide or tell which button I want to use. Okay, so I'm going to right click and I'm going to create a constant. All right. So the enter button, which is the center button, is the default. Okay, I just want to move this up a little bit. I'm having trouble. Anyway, I'll just leave it here. All right, so let's say I want to use the down button to ring my doorbell. And you can use any button you want. Okay, come on over here. I'm going to right click. Still trying to move that up. I am determined. There we go. All right, if you get a wire that isn't looking like it's going to the terminal, click on the wire, clean up wire, and it'll make it go right to that port more obviously. All right, so coming out of here is a yes, no, which means a Boolean. True if the button is pressed, false if it's not pressed. So we come in here, and in the true case, I'm going to put this up here. I'm going to play a poly sound. Okay, so I'm going to right click I/O, and there's sound. Wow, there's mail. I can get email here? Okay, anyway, so there's tone. So I'm going to right click visible item just so you can see there's poly sound. Okay. So I'm going to come in here, duration. You can right click. You're going to create a constant. This is 500 milliseconds. And up at the top here, there's the tone. I'm going to create a constant there. So I'm just taking the default 440. And on each of these things, you can do visible items too. So I can do that, visible item, label, duration. So now you know everything that's going in there. In the false case, let's go up above. You don't want any sound. So you're going to put polysound stop. So go to IO sound, and then you're going to put stop song. Stop song. I guess you're stopping the song. Right click, create, no, visible item, label, polysound. So pretty easy program. True means I'm playing this note for 500 milliseconds every time I hear get the button pressed. Or if the button is not pressed, it's not going to play anything. So you get to hear some beeping. You can play around with the sounds. There are ways of downloading music and sound files to the EV3. I'll leave that up to you. Doorbell is now done. So now you should know how to create and communicate with your brick via the buttons and know how to use the sound.